let's start off our lesson today with a little joke. So, what did the boy volcano say to the girl volcano? And he said, I love you. Okay, so today we're going to talk about 3 different kinds of relationships to introduce Chapter 8. The first kind of relationship is just a direct variation. It's a very simple relationship. It's linear. Y equals k times x is an example of direct variation. So all this means is when x gets bigger, so does y. So if we have the equation y, let's make our constant, k stands for any constant. Let's make our k 3. This is one specific example of direct variation. So let's say our x is 1, then our y would be 3. If x gets bigger, let's say x is 2, then our y would also get bigger, it would be 6. So that's direct variation. Now let's talk about inverse variation. Inverse variation is kind of the opposite of that. Instead of your x being multiplied by your constant k, your x is going to divide that constant k. So one of these equations would look like, let's say y equals 5 divided by x. So if I have the point 1, if I plug 1 in for x, I would end up with 5 for y. If I plug 2 in for x, then I have 5 divided by 2, which is 2.5. So if my x gets bigger, my y would get smaller in an inverse variation situation. We haven't discussed what graphs like this look like yet. For direct variation, they're just lines. They actually all will have a y-intercept of 0, which makes them even easier to deal with. Now let's talk about joint variation. Joint variation is just when more than one thing is going on at a time. So y equals k times xz would be the general equation for joint variation. So an example of that would be y equals 1/2 times x z. So now you have 3 variables going on. So if the x gets bigger, the y gets bigger. If the z gets bigger, the y gets bigger. But the x and the z are on the same side of that equation. So if x gets bigger and y stays the same, then z has to get smaller. We'll talk about an example of that as we go on. So here's our direct variation example. So this is one thing that you're going to be asked to do with these problems. You're going to have to find what that constant k is. So the first thing you should know is try to write the general equation. So 2 variables, x and y, vary directly. That means this first sentence lets you know that you are in this situation, that you have that basic general equation. Now it asks you to find the k if y equals 4 when x is 5. So just plug in those values and solve for the constant k. So 4 equals k times 5. If I want to solve for this k, I just simply divide both sides by 5. And k equals 4/5, which is 0.8. Sorry, I just had some kids come in and try to mess up our recording. Alright, so now I have the equation y equals 4/5 x. So this is just a line with a slope of 4/5, and that's all you have to do, find the constant. Alright, so now let's talk about inverse variation. So inverse variation is just when we're dividing by the variable instead of multiplying by it. So 2 variables, m and p, vary inversely. That lets you know that you have this situation. Instead of writing x and y, I was trying to be a little bit fancy and make it m and p. I know you guys are so excited now. Alright, so now it says if m equals 9, when p equals -27, find the k. So let's plug those values in. If m equals 9, when p equals 27. So now all we're doing here is trying to solve for this k first. So in order to solve for the k, I'm going to multiply both sides by -27. Oh, that is off the top of my head. 27 times 9 is 243. So here I get that k equals -243. So now I know that my equation is m equals -243 over p. So this is my equation. Then there's another piece of directions. It says use this information to find P when M is 4. So if M is 4, I want to figure out what the P is in order to make this equation true. Sorry for the interruption. It was a wrong number calling for Ben and Jerry's. This is not going well today. Okay, so now let's try to solve this equation for P. In order to solve for P, I have to get the P out of the denominator. And in order to do that, I'm just going to multiply both sides of the equation by P. So those P's will divide out, and I have 4P equals negative 243. Come on. I don't know what is going on today. Okay, so if we divide by 4, then I get that P equals negative 243 divided by 4. This cannot be simplified, and that's just your answer. So the problem asked you for two things. It asked you to find your K so that you could write your equation. That was the answer to that. Our K is negative 243. And then it asked you to find the P when the M was 4. So that was this one was. So now let's move on to the next example. So here we're talking about joint variation. The volume of a prism with a square base varies jointly. Write the equation for the volume of the base. Write the equation for the volume of the base based on its height, h, and the length of its side of the square base. So I'm just going to draw a little picture for you to refresh your memory from geometry. So here is a prism with a square base. Some of you may be doing this actually right now in geometry, you just tested on it. So this square base means that this side and this side have the same length, and this is our height. So let's try to write an equation for the volume of this solid based on its height and the area, and the S, the area of its base. So in order to find the volume of a prism, you just multiply all the dimensions together. So it's S times H, which is S squared, H. So now you can see here that volume varies jointly with the square of S and H. That's an important sentence. The volume here varies jointly with the square of S and H. So this is an example of joint variation. So in this example, what would the value of the constant be? So the constant is just the number that multiplies in front of the S squared H. And here is that constant. It's just 1. Do not forget to answer the questions. If you do not answer the questions before the time that our class starts tomorrow, I will not be giving you credit. I will not let you do it in class. All right, have a good night.